Hello everyone, I welcome you all to my first video of Virtual Guru channel, and here I'm going to teach my very first chapter, that is trigonometry. It's a very easy chapter and interesting chapter you'll find in the whole of mathematics, and let's begin. So what is trigonometry? It's just a branch of mathematics that deal with the relations between the sides and the angles of triangle. So if you're taking this particular side, now what is its relation with this particular angle and this particular angle and this particular angle? That's all. So you will find some functions and you'll write some equations. It is all about that. So why do we have to study trigonometry? Trigonometry can be used in surveying, that is for distance of the shore from one point of the sea and all, then navigation to pinpoint a location. Then it is also used in celestial mechanics. Now, what is trigonometry means? It's a Greek word and trigonon means triangle and it's trigonon and metry means to measure. So that is how the word trigonometry came into use. Next, um, how was trigonometry used in the past years? It was used by a very good and well-known navigator called Ptolemy. He used trigonometry while he worked for the geography formation and all. And Christopher Columbus, he used it for finding its way to Spain, to what he thought actually was India. So that's how trigonometry have been used in our ancestral Greece. Okay. Next, coming to our first chapter, that is Introduction to Trigonometric Ratios. That is the first and foremost thing you will study when you are studying this field of mathematics, that is trigonometry. So, you have to know first and foremost three words, which is hypotenuse, opposite, and adjacent. All three define the sides of a triangle, especially right angled triangle. So, what is this hypotenuse? So this hypotenuse of a right triangle is always the side opposite to the right angle. It is the also the longest side of the right angle. So what is a right angle triangle? Right angle triangle is one such type of a triangle which is having one of its angle at 90 degrees. So this particular angle is at 90 degree as you can see here. So the side opposite, exactly opposite to the 90 degrees angle is called as the hypotenuse. Okay, so this is always the longest side of the triangle, and you might have learned this hypotenuse word in something called Pythagorean theorem. Okay, so in that theorem, Pythagoras has already defined the side that is opposite to the right angle triangle square, right angle, the square of it, that is AB, length we are going to write, is always equal to AC square and BC square. This is how you must have studied in your Pythagoras theorem. If not, let just keep it as a knowledge. You might find it useful in some other subject. Okay. Now there are other two sides. There are names for these also. Now we will say how these are named. Okay, so the other two sides are called opposite and adjacent. These sides are labeled in relation to the particular angle. So other than this 90 degree, there will be another angle in trigonometry depending on which you'll be naming it. So take it as anything, like for example x. X can be any angle. Most of the time it will be an acute angle anywhere between 0 to 90. So it can be x, or you can name it anything. And now with respect to this angle, we are going to name other side. So this whatever is opposite to this angle x, that is called as opposite. Then whichever is adjacent to x, that is called as adjacent side. Adjacent means next to. Okay, now we might think like hypotenuse is also adjacent to x, isn't it? So you will always choose the adjacent side, which is a non-hypotenuse side, because already you would have find the hypotenuse. That is how opposite to 90 degrees. So that is done. We have labeled it hypotenuse, not touching it. Now the other one, which is adjacent to that particular angle, that is x, that we will name it as adjacent. So adjacent side is the side that is non-hypotenuse side, that is next to a particular angle. And opposite side is formed across from a given angle. So here our opposite side is BC. This is how you represent a line segment with a bar in the top, and AC, that is our adjacent side. So these are the basic words to describe a right angle. So if you put all together, you can see it will be named like this. Now if I have to write for B, let me change the color. So for B, with respect to B, which will be the opposite side. So right angle is formed in the same place, that is at the angle C. So that will not going to change. Hypotenuse will be the same. So with respect to angle B, which will be the opposite side? Opposite to B is the side AC. So the opposite side changes to AC. But adjacent to B is one hypotenuse that's already labeled. So the remaining side is this. This will be labeled as adjacent, which is a non-hypotenuse side. So with respect to B, everything changes. Okay, this is how we label the sides. Okay, continuing, I'll give you some examples to figure out how we are going to find adjacent, opposite, and hypotenuse side. So consider this triangle BMG. So if somebody asks you, like, which is the adjacent side of angle G? Okay, so the question is, which is the adjacent side of angle G? So you have to mark an angle G here. And the adjacent side is the one which is the non-hypotenuse side. Is it correct? Yes. So right angle opposite to this is hypotenuse. So obviously the other side will be adjacent because this is the opposite. Don't get confused, dear students. Opposite is exactly to the front and adjacent is next to. So that is how you decide which is adjacent. So our adjacent side is therefore GM. You put a bar to indicate line segment. Next, if another example, which is a triangle or a right angle triangle, NED. Here, as you can see, right angle is formed at N. So, what is the opposite side of angle N? So, opposite side is the one which is exactly in front. So, it will be exactly in front. That will be ED or DE. So, this will be our opposite side. Next, our next example will be SYK. So we have your question is in the triangle SYK, find the hypotenuse. So hypotenuse is the side which is opposite to our right angle, that is Y and K. So the answer will be YK. I hope it is clear with this. This is just the basic. If this is clear, you can go on very smoothly in trigonometry. So now you might think, why are these words very important? So we are about to learn the trigonometric functions further. That will be sine, cosine, and tangent. There are other three trigonometric functions, but for now let's stick at the basics. So that is sine, cosine, and tangent. Here we will define these words: adjacent, hypotenuse, and opposite. I'm going very slowly so that this particular concept is very, very clear. Now we are going to study the part 2 of our chapter, Trigonometric ratio. So what are these trigonometric ratios? So the ratios of the sides of a right triangle are called as trigonometric ratios. So it will form a different ratio like opposite by adjacent, adjacent by hypotenuse, opposite by hypotenuse. All these are called as trigonometric. So there are terms for that. The common trigonometric ratios are sine, which the symbol of sine is SIN. Then cosine, the symbol of this is COS, cos, and tangent, that is tan. This is how we will represent sine, cosine, and tangent. If you look at this particular right angle triangle, this will be our right angle. So we will take our reference, that is the particular to angle X. Then this is how the angles are named, A, B, C. Then how do we find sine of angle X? So how do we find sine of angle X? That is equal to opposite by hypotenuse. Can you tell me which is a hypotenuse here? Yes, angle AB, because it is opposite to right angle. Then which is opposite side here? That is nothing but opposite to angle X, because we are writing sine with respect to angle X. So this will be opposite will be BC. So our opposite side is BC. So we can write this as BC by what is the AB. This is sine. So same way we can write even cos of X. I'll just erase this one thing. Cos of X can be written as cos of X is equal to the adjacent side. So X is nothing but an angle who's having an adjacent side of AC. Why AC? Why AC is called adjacent? Because it is a non-hypotenuse side next to X. So that is the side we have to mention. So cos is nothing but adjacent by hypotenuse. This is a formula for writing cos. So what is the adjacent side of X? That is AC. And what is the hypotenuse? That is the same, AB. So this is how you write the cos. Okay. Next, going further, I'll show you how to write tan. How do we write tan? So tan is nothing but tan of X. Okay. Tan will be opposite by adjacent. So opposite by adjacent. So we know what is opposite to X, BC. What is adjacent to X, AC. This is how the tan of this particular angle X is determined. Okay, so this is some of the, so it is a way to describe these three particular trigonometric ratios. Now, you might be wondering, how can I remember all this opposite by adjacent, opposite by that, this? Okay, it's quite simple. I'll tell you one very well-known formula or a way or a trick that my teacher used to make us learn so that we don't confuse between opposite by adjacent, what is sine, what is cos and all. So that is nothing but so ka toa. So what is a SOHCAHTOA? SOHCAHTOA is a trick which can be used to so that we can define what is sine, what is cos, and what is tan. So I'll show you how is it done. So S is for sine. For example, if we are using sine somewhere, for example, sine of theta, this is how a particular angle is defined, like theta, phi, psi. There are so many ways, so I'll take this one symbol. It is very commonly used, so let me use that for now. So sine of theta is nothing but opposite by hypotenuse. So this is how sine of theta is defined. Next, cos of theta. Where can you see here in the car? So cos of theta is defined as adjacent by hypotenuse. Next, tan of theta. Where can you see a t here? It's here. Tan is nothing but opposite by adjacent. Okay. Now, how do I relate all this to what I have taught earlier? I'll show you. See, S is for sine. If you want to write sine, remember so. So that is S is for sine, O is for opposite, H is for hypotenuse. Same way, in car, C is for cos, A is for adjacent, H is for hypotenuse. Then comes tangent, that is TOA, that is T is for tan, O is for opposite, and A is for adjacent. So this is the trick used for representing sine, cos, and tan. Just remember so, ka, to. That's the trick. Now, I'm going to solve some examples so that it will be clear how it is going to appear in any type of exams or in your exercises to solve the problems very easily. So, first thing is, first problem, in triangle A, B, and C, what is our sine A? This is your question. You have to find what is sine A. Okay, this will be given to you. The length of the sides AB is 5, BC is 3, and AC is 4 is also given. You have to write what is sine. So what will the sine be? The sine is defined as, okay, for example, you forgot what is sine, the definition of sine. So you can just remember what I told you. So, ka, toa. Of course, ka and toa is not required here. With the definition of sine, we can write S is nothing but sine, that is here sine of A. Then O is nothing but opposite. Then h, that is hypotenuse, will be divided by hypotenuse. So you found your formula with just this SOHCAHTOA. So now we have to find what is our opposite side. Opposite side to A. Why we are writing A? Because this is our particular angle. In relation to this, we are going to find in this particular sum. It's not always A, it is in this particular sum. So opposite to A is BC and hypotenuse is obviously in front of the right angle, that is AC. So BC, what is the length of BC? 3 centimeter, 3 inches, 3 meter, whatever. Then AC is 4. So our answer is 3 divided by 4. This is our answer for the sum sine of A. Okay, is it clear? Okay. Moving on to our next sum. So now we have to find in this particular sum what is cos of f. This is our sum. So what is cos of f here? So we come to know from f that this is our angle that we are interested in. This is our right angle because, yeah, obviously this is 90 degree. So cos, what is cos? Cos is ka, that is c. Cos of f is a, that is adjacent by hypotenuse. So what is adjacent here? Adjacent is nothing but an angle that is and the side that is just next to f, that must not be the hypotenuse side. So this is our hypotenuse, and because it's opposite to 90 degree, and this is the adjacent, it's a non-hypotenuse side. So that will be df by ef. Am I correct? Yeah, yes I am. So what is df? 13. So what is DF will be 5 and EF will be 13. So this is our answer. Cos of F is 5 by. Next, for the same problem, if you had to find the sine of F, what is sine? Sine is nothing but, oh, sine's opposite by hypotenuse. What is the opposite side here of F is 12, or you can write ED, or you can just write directly 12 by 13. Next, if you had to find tan for the same sum, so I'm very sorry, it is looking very messy because I'm having a very small board. Okay, tan is nothing but we can see in TOA that is opposite by adjacent. So opposite here is nothing but opposite is 12. F opposite is 12 and adjacent is nothing but 5. Yeah, so this is our answer. Okay, moving on to our third sum, that is in triangle G, H and I, uh, which are the sides, that is 17, 8 and 15. This is our right angle, this is our reference angle. So in the triangle G, H and I, tell me what is cos of G. So what is cos of G here? Cos of G is nothing but, remember this, so uh, Toa, Toa. So cos is nothing but adjacent by hypotenuse. Angle G with reference to angle G. What is the adjacent one? Adjacent one is 17. Next two is G 17, not 8. I'm sorry, it's 8 and not 17 because 17 is our hypotenuse. So obviously 8 is the adjacent side, so it is 8 by 15. Next, I'm sorry, it is 8 by 17. Okay. Next, what is our sine? Sine of G. Sine of G is nothing but, so it is opposite by hypotenuse, which is the opposite side here to G is 15, as you can see 15. Then the hypotenuse H, that is 70. Next, if you have to write tan, so what will be tan here? Tan is nothing but tan of G. So tan is for tangent. That is tan is nothing but opposite by adjacent. First letter will come in the numerator, second letter will come in the denominator. Don't get confused. And the opposite one for G here is 15 and adjacent one is 8. So this is our answer. So now it is our new triangle. So I have not named the sides and all as it's not necessary here. So in this particular right angle triangle, can you tell me what is AC? A by C. Whether it is sine, whether it is cos, if it is sine, whether it is sine 70 or it is cos 70. As you can see, there is an angle formed here. A and C intersection, that is 70 degree, and B and C intersection 20 degree. So whether it is sine 70, cos 70, or it is tan 70, then if it is 20, whether it is cos, sine or tan. Remember, you can have two answers here. So we are going to find what is this is. So AC, we know that. What is our hypotenuse here? C, isn't it? C is the hypotenuse, which we can easily tell from the figure because it is the one having the 90 degree. Next, then what will be our, if it is in relation with to measuring the angle 70 degree, then that is with reference to 70 degree, what will be our adjacent side? Adjacent side with respect to 70 degree, it will be A. Okay, this will be our adjacent side, and B will be our opposite side. They have asked A by C. A by C is nothing but adjacent side and hypotenuse. So, which definition is adjacent by hypotenuse? That is nothing but cos. So, this A by C is nothing but cos. What is our angle we took our reference as? Yes, so it is cos 70. Okay, okay. There is another answer for this. You can write with respect to 20 also. So, with respect to 20 degree, as you can see, hypotenuse will not change because it's the same triangle having the same 90 degree at A and B intersection. So C is the hypotenuse. Now, with respect to 20 degree, what is our opposite side? Opposite side to 20 degree will be A, isn't it? So A will be our opposite, and C is hypotenuse, and B will be our adjacent. They have asked A by C. A by C is opposite by hypotenuse. That is the definition for sine, because you remember. So opposite by hypotenuse. So that is nothing but sine. Sine of what? Is it 70 once again? No, it's 20 degree, as we have I have already told you this is reference with 20 degree. So the answer is 20 degree. This is one type of sum. Okay, consider this particular type of sum. So in this triangle, you have to find what is h. How are you going to find what is h? So h is nothing but the opposite to her right angle, that is hypotenuse. So as I have told you, if you have studied the Pythagorean theorem, you will know that hypotenuse square is nothing but other two sides of the triangle. That is 4 square plus 7 square. That is 16 plus 7 square is 49. So 9 plus 6 is 15, and this will be 65. But we know that it is h square. Is it a perfect square? No, it's not a square number. So we cannot find it a perfect number. We have to just keep it rational 65, root of 65. So we found the answer. H is nothing but root of 65. As you can see, we cannot just write some number into twice inside the root so that we can take it out. So this is our answer using the Pythagoras. Yeah. Okay, that's all for today. I have solved every example very slowly for you to grasp every concept of the basics of trigonometry, that is hypotenuse, opposite, adjacent, and sine, cosine, and tangent. There is no way you can forget the principles if you have seen this video properly. So thank you once again. Do like my channel, Virtual Guru, and please subscribe for getting all the new videos and notifications in your YouTube YouTube window. So thank you. Have a good day, everyone. Bye.